tickets for a concert cost $10 each if you order them online, but you must pay a service fee of $8 per order. The tickets are $12 each if you buy them at the door on the night of the concert. Graph and find the intersection. Okay, so this is a real life situation here. We have two equations we're going to create. One equation is if we buy tickets online. The other equation is if we're going to buy them at the door. Okay? I'm going to let y be my total cost, and I'm going to let x be the number of tickets. Okay? The first equation will be if we buy them online. I'm going to get y equals 10x plus 8. Okay? It is $10 per ticket. So that's where the 10x comes from. We're multiplying 10 times the number of tickets. It's $8 per order. Not per ticket, per order. Alright, this is very much a real life situation. If you use Ticketmaster, StubHub, Live Nation, I think is one of those, right? Like, they're going to charge you a fee on top of the cost per ticket. So that's what's happening. Obviously, it'll be more money than these. We're using friendly numbers, but that's a real life thing. Okay, so it'll be like some kind of service fee and then an amount per ticket. The other equation, if you just buy it at the door, it is $12 per ticket at the door. So our other equation is y equals 12x. We do not have to write plus 0 because there is no initial fee. But we have to understand that when we graph this, our intercept is going to be 0 for this equation. Okay? Now we can start to make our graph. Because we're trying to solve this using the graphing method of systems. So, this is concert cost, right? The y-axis is the cost. The x-axis is the number of tickets. All right? On the x-axis, I'm going to make every 2 boxes be 1 ticket. All right, so 1, 2, 3, 4, 5, 6. On the y-axis, I'm going to use 10 and kind of estimate exactly where we're going to be, right? And I'm going to go every 2 boxes is 10. So 10, 20. So I'm actually really going by 5s each box, right? 30, 40, 50, 60, 70, and so on, okay? The first equation is very simple. We're starting at 0. I'm going to do this one first, okay? Let's do this one in red. Y equals 12x. So we're going to start at 0, 0. At 0 tickets, there are 0 cost. Okay? And we're going to go up 12 and to the right one each time. So about here. And then we'd have $24 for 2 tickets. And then we'd have $36 for 3 tickets. And then we'd have $48 for 4 tickets. And then we'd have $60 for 5 tickets. And so on, right? Now, am I going to draw the line on this? No. This is a discrete situation, right? Most of the time we're drawing the line, right? If there's not a word problem, you draw the line. If it's a continuous situation, you draw the line. But each ticket is a separate thing, so we don't have to draw the line. It's a discrete graph. I'm now going to graph this one, the y equals 10x plus 8. This is if we're buying it online. Our intercept is 8. That means at 0 tickets, we still have to pay the $8 service fee. And then it's going up by $10 per time. So $18 for 1 ticket, $28 for 2 tickets, $38 for 3 tickets, $48, ding, 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 there's our overlap, for 4 tickets, $58 for 5 tickets, right? And we get $68 for 6 tickets and so on. We understand that? Questions? So this point right here is the big point. This 4, 48. It's the overlap. Okay? This means that at 4 tickets, the cost is going to be $48. Now we may want to know why this is important. Depending on how many people are going to the concert will depend on where you should buy the tickets. If 4 people are going, if you and 3 friends are going to the concert, it doesn't matter whether you buy them online or at the door. It's going to cost the same amount. If less than 4 people are going to the concert, if it's just you and 2 friends or 1 friend, okay? Maybe it's a date, who knows, right? You should be going and buying the tickets at the concert. It will be cheaper for you. It would be more expensive to buy online if there's less than 4 people going. If there's more than 4 people going, now it'd be smarter for you to buy it online. It would be cheaper to buy the tickets online. It'd be more money to buy it at the door at $12 a ticket for more than 4 people. This is why this is important. Again, we can also check to make sure our answer is correct. By substituting 4, 48 in for x and y, we can determine if both of these equations are true. So if I substitute 48 in for y and multiply 12 into 4 to check for this equation, 12 times 4 is 48. See how it works? But to check a systems of equations problem, we have to make sure it works in both equations. So when we take the y equals 10x plus 8, we substitute 48 in for y, so y equals 10 times 4, because that's what x is, plus 8. 10 times 4 is 40. 40 plus 8 is 48. And 48 equals 48, so it checks out for both. So there you have it. 4 tickets, $48.